So on 11.2's homework, students are going to be continuing to practice the conversion like they did on 11.1. And the same metric conversion exists. So whenever we have the unit, so yesterday our unit was meters, today our unit is gram, it's always going to translate of needing 1,000 to make a kilogram. So if we know that it takes 1,000 grams to make 1 kilogram, students should be able to figure out how many go here, how many kilograms are here, what the missing numbers are, knowing that there's 1,000 grams in every kilogram. So have finished students go ahead and finish that table. For the converting measures, what we practiced in class was changing, in this case, the kilograms into grams, using that understanding that 1,000 grams are in every kilogram, and then combining it with the grams that are listed in the problem. So for this first one, we'd see 2 kilograms. Underneath, students may want to write that as 2,000 grams. It's a conversion. Plus the 700 grams mean that there's a total of 2,700 grams. So they're going to want to change 5 kilograms into grams, 29 kilograms into some number of grams, 31. And then on E, what they're going to want to do is say, well, now I have grams, how many kilograms is that? And if we remember this big concept up here that 1,000 grams is in 1 kilogram, if I have 66,000, that means that I have 66 kilograms, because 66,000 grams is equal to that. And then I'd keep the remaining 597 grams as is. Once students are done with 1 and 2, they can come down and solve here. So for the addition, once they solve that, again, they're going to want to take any number over 1,000 and change it into kilograms. So for 3, A and C and D, when they're adding anything over 1,000, they were going to want to change into a 1 kilogram. So always remembering that 1 kilogram is equal to 1,000 grams. So anytime they have 1,000 grams, they can do that conversion. For problems like B, where they're subtracting, there's multiple ways they can do it. The first way we learned today is change everything into the same form. So in this case, make 5 kilograms into grams, calling it 5,000, subtract 730. Students can solve and then reconvert anything over 1,000 grams into kilograms. That's one method. Another method that we talked about, I'm just going to move this over so that I can use the original problem. Students can take this 5 kilograms and make a number bond. So they could say, I need to subtract grams, so let me take out 1,000 grams. That will leave me with 4 kilograms, because that number bond is still true. 4 kilograms plus 1,000 grams is still 5 kilograms. But now I've created some grams that I can now subtract the 730 from. If students solve this way, they end up with some number of grams, and they keep the 4 kilograms intact, and then they have that mixed unit answer. If they use this method, they have to return the grams into a mixed unit of kilograms and grams. On problem F, there's another method that students can use. They can first subtract the kilograms. So 70 kilograms, subtract 17 kilograms, and get sum total of kilograms. So whatever that number is. Then that number of kilograms and the 101 grams, then they can subtract the 862. And again, they can decide to change this whole number that they just solved for into grams, or they can break it into 1,000 grams and whatever one less kilogram, and that will also solve it. On the back, same as yesterday, they want to do a tape diagram. So the tape diagram, I always like to have students do a visual model first and then the tape diagram. So it says one suitcase weighs, so I'm going to draw a picture of a suitcase. It weighs 23 kilograms and 696 grams. Another suitcase weighs 25 kilograms, 528 grams. What's the total weight of the two suitcases? So if I did this visually, I'd know that I have to want to find that for the total weight of the suitcases together. For the tape diagram, it's still similar. You know 2 parts. You know 23 kilograms, 696 grams, and you know 25 kilograms, 528 grams, and you're looking to find the total. So that's the tape diagram, and again, students would just combine those two values. So here we have a bag of potatoes and a bag of onions has a combined weight of 11 kilograms and 15 grams. And remember, this is both onions and potatoes. If the bag of potatoes weighs, so just the potatoes, 7 kilograms and 300 grams, we want to figure out how much the bag of onions should weigh. So this is a good picture to show it. The way you'd show it is a tape diagram. We know the total weight of both, 11 kilograms and 15 grams, and we know the weight of the potatoes. We know that the potatoes are 7 kilograms, 300 grams, and we're missing what the onion should be. So those are the tape diagrams for that one. So the next one shows a table of weight of dogs, and we want to know the difference in weight between the heaviest and the lightest. So difference tells us we're subtracting, and we want to take the heaviest, subtract the lightest. So that should be easy to do, but what I would suggest students do here and here is convert these both into total number of grams so they can compare it to the third one they see there.